Today's guest is Daniel. So thanks a lot, Daniel, for joining us.
I'm super excited to talk with you about TDD in this case.
So let's start with what is TDD?
TDD is not equal to testing. Represents three things.
Does test-driven development make sense without unit tests? Does test-driven development work well when collaborating with testers?
Whenever people talk about TDD, they talk about PDD as well. Do you think TDD is for everyone?
Three phases, as you see: red phase, green phase, and refactor phase. So before we start, there is one law we need to follow.
What are the resources which you recommend to learn about TDD?
I love automated testing, so I'm excited.
Hey everyone, welcome back to another episode of This is Tech Talks. And we have our co-host Lars today with us. Hey Lars, how are you doing?
Hello, it's nice to see you, Daniel, Santosh.
So, and today's guest is Daniel. So thanks a lot, Daniel, for joining us, and hope you will enjoy this conversation which we are going to have.
Absolutely, and thanks a lot for inviting me for this great show. I'm super excited to talk with you about TDD in this case.
Yeah, very interesting topic. What do you think, Lars?
Exactly. Well, I love automated testing, so I'm excited.
Awesome. Then you are my friend.
Great. So, unfortunately, Jay is not joining us today. He has some work, but we are missing you, Jay. Let's hope to see you on the next episode. So let's go ahead and get started, Daniel. So first, we would like to introduce yourself, like what you have been doing so far, and like what you do at your free time, maybe. So do you write blogs or whatever you do in your extra time?
Absolutely. So yeah, my name is Daniel Moka, and I'm from Hungary, and I'm a software crafter and coach, helping teams and individuals to craft better software and write quality software. And yeah, in my past is that in the last 10 years, I've been involved in many different kind of projects in different countries. I know, starting from Germany, Netherlands, Austria, France, Hungary. And I was involved in many different kind of domains as well, such as gas and oil industry, healthcare, robotics, and other kind of domains. And I realized one thing that in all the domains and all the projects I worked in, there was one practice I could always use. And that practice is test-driven development. So, and the more I switch tech, I always apply it, and I realize how powerful TDD is. So that you guys invited me to talk about this TDD, and that's what I'm doing in my free time. I'm trying to help people on social media to teach them how to do TDD, and of course TDD. We will talk about what is TDD, but TDD is just not a simple practice. It consists of a lot of different kind of things, such as writing tests, designing code. It's a complete package of designing, testing, and developing software. So in my free time, that's one of my hobby that I'm helping people.
So let's start with what is TDD?
Absolutely. So yeah, there are many first, let's start with the misconceptions. There are many misconceptions about TDD. For example, TDD is not equal to testing. Many people think that TDD is equal to testing, which is partly, I would say, true, even not halfly. It has something to do with testing, but it's not equal to testing. There are also people who think, okay, then you have to write, because everyone heard, okay, TDD, we have to write or test first. But it's not about that you need to write all your tests first. And also, it's not also that you need to write one big test first and after that the production code. For me, TDD represents three things. First of all, is a design methodology. It helps us to produce testable, well-tested, clean code with good user experience, verified user experience. Second of all, it is a development tool for me, because it contains two things. One is the TDD cycle, the red-green refactor cycle. So write the failing test, make it pass refactor. But next to it, there are three laws, which later on I will go into it, which really it forces you to take baby steps. So it's a development flow to really write code in a small steps, and you verify every step along your way. You test every step what you take. So it really results in a safe and incremental way of writing software. So this is the second. So first was it's a design methodology for me, a development tool, and last but not least, it is also a testing approach for me. And why? Because if I use TDD, or if you use TDD well, then we end up having a code with test suite having 100% code coverage, but not only code coverage, but also behavior coverage. Because code coverage is a misleading metric, but I'm not going to go into more detail because it's another topic. But it's a misleading metric. Code coverage doesn't tell anything about, it just tells whether your code is executed or not. It doesn't tell whether your code behaviors are asserted by your tests, and that's the most important thing. So you can have 100% code coverage without any test assertions, which is a crazy thing because everyone is really nowadays teams focused on code coverage tools that, okay, let's reach 100% code coverage, but it's not enough. I mean, as I said, let's say you have 100% code coverage and you remove all the assertions of your test. And if you run your code coverage tool again, you have 100% code coverage. So that's not the best tool. So what I wanted to say, it's a testing methodology, a testing approach where you end up with a code with full coverage, but also the behavior coverage. So for me, these are the three things which represent, and we can go into these in more detail.
Yep. Do you have any questions?
Yeah, so we're talking about test-driven development, and you're saying it's not only, or maybe only half of it is about tests. So does test-driven development make sense without unit tests, or are they a central part of it? Is there any other form of test that you can do with test-driven development?
Excellent question. Thanks for bringing it up. TDD is mainly about with unit test. But I would say there is one characteristic what your test should have, is that they should be fast. And why? Because we run them every step. If it is a system test, if it is an integration test, whatever, they have to be fast. Sometimes you have a CLI application. That's the whole system, let's call it. We have a CLI application, that's a system. System test is, that we run, the binary, and after that it produces something on the standard out. So in that case, you can write those, it's a system test, but they can run pretty fast. So we can use those tests in a TDD flow. So yeah, great question. Surely about unit test, but we have to be careful about that. There are also bad practices people are doing with the unit testing. They really couple their test to the implementation details. So therefore, lately I hear a lot of people that, hey, you shouldn't use unit test. Let's use integration test. They give you better confidence. But they say it because, a lot of people are doing unit testing wrong. You shouldn't test low-level implementation details. You should test always behaviors. So TDD is about driving your design by writing automated tests where the tests targeting behaviors of the system.
Yeah, I love it because it's also one way of documenting the code from a developer perspective. So if you don't have any other form of documentation, the test is where you can go to find some understanding. It also works well in open source, right? Even if you think the documentation is lacking, you can hopefully go into the tests in the project and see, okay, so this is how it should be behaving, as you say. What will happen if I send it, if I configure it this way and send it these values? That should hopefully be in the test suite.
Exactly, absolutely, and you are having a good point there. And I would even say that if a well-written test suite targeting behaviors is a better documentation than the README, because README you have some simple examples. You don't have all the paths, you don't have all the edge cases. But in a test, when they are written well, and it covers all the functionalities, then they are well written, it has good naming, good structure, good assertions, then they are even better than the README. So yeah, you are having a great point there. And that's what I also do. Anytime when I want to use a new library, I check its tests. And if they don't, and if the given library doesn't have a test, then that's a red flag for me that maybe this library is not the best to use.
Yeah, it's something we have gotten to expect from high quality open source projects. Definitely.
Exactly.
I have a situation where it's what you mentioned. I'm maintaining a sort of a very specific state management library for state router state in particular in Angular. And even though I have 100% test coverage, I can keep adding hundreds and hundreds of tests because there's so many different, like you say, edge cases and different things you can configure. I mean, it's a router. You have to think of all these different ways. The Angular router in particular is very, very advanced and flexible. So I'm trying to cover as many of these scenarios as I can come up with, and as I've seen in practice, lots of edge cases in production code bases and so on. So I'm trying to integrate all of that into the library so that I know it works under all these circumstances, how it behaves, also that it matches the behavior of other libraries, that so that there's a migration path, or even from the Angular router itself, so that there's an easy migration path, and you can expect the same sort of values from this library and behaviors.
Exactly, absolutely. They give you confidence, and that's where really TDD can help. That namely with TDD, since with TDD we have to start with a failing test. That's the first thing. We don't need to start with a big failing test, just something which is sufficient to fail. And sometimes a compilation failure can be also a failure, but something really minimum that fails. And after that, once we have this failing test, we need to make the test pass by writing some production code, and after that it's time to refactor. And because we do this, we do this 3-phase cycle, the write a test, make it pass, refactoring. Therefore, every code we write should have a corresponding test. So therefore, that's what I mentioned at the beginning, that if we follow TDD, we end up having, of course, we are humans, we can make mistakes. But if we follow TDD properly, we end up with a code having 100% code coverage and mutation score of behavior coverage as well. But as I said, so again, when we discuss now about the TDD, about testing, and you're right, it has things to do with testing, but I would say this, that you have a good test suite, is just a byproduct of TDD. This is not the main goal of TDD. The TDD, I would say, the inputs are the tests, and the output is a well-designed, refactored, and clean code. And that's the biggest power of TDD for me, that it helps me to design software. Because again, we start with the failing test. The failing test really the foundational part of TDD, and not only that it validates the test is meaningful and unique, but it also, when you test something, the tests are the first users of your code. Test, because that's the first user before even your user starts using it. Test are the first user. Test where you execute and exercise the system under test. And since you do it already, you start with the failing test, you already designing how the signature of the API should look like. Let's say, what are the inputs, what are the outputs, how about the naming, how about the side effects. You already think about this at the red phase. You already think about the design of the code without implementing it. So you can already catch mistakes, so you don't need to, do rework in the future. So that's the main power for me, the TDD, that it helps me to really think about from the client's perspective, right? Because it's all about, we are writing software for, the clients, for the user, how the user will use our software, or we write some APIs for other developers who are also users, and they will use it. And then we write code with TDD, then, as I said, when we have the failing test, we already see, okay, this is the code, and okay, this will be used by someone, because, in the test context, you're using your code, right? You are executing it. So, how it looks like, whether I like it, or good naming, good signatures. So it's really one of the power that you verify the user experience of your code. Of course, other testing is needed, TDD, and that's why TDD helps with unit tests, or writing a good test suite, but still there are other practices you need to do to cover. So it's not a testing strategy, surely not. It is one way to have some good tests for your code, a very good test suite, a suite that you can trust. And that's one of the key things here, that you can trust your test suite. Again, it has a good code coverage and behavior coverage.
Does test-driven development work well when collaborating with testers? So colleagues who are not writing code, except maybe for, I don't know, Gherkin specs or something like that, but testers who are experts in figuring out edge cases and failure paths of users and things like that. How do they fit into test-driven development, the tester professionals?
Exactly. Yeah, this I have multiple thoughts about this topic now. But surely, let's say you have some acceptance criteria, right? Acceptance criteria. You can come up with a test case, and you can even use some high-level tests, like the acceptance test-driven development. There is a practice like that. You have a acceptance test. Let's say you spin up something. You spin up something in the browser. There is a form. The user fills the form, clicks on I don't know, enter, or clicks on the button, and after that, something should be displayed on the user interface. So it's a very high level test, and it can be written in with Gherkin languages. So testers can do that. So in that sense, yeah, absolutely, it fits. On the other hand, my other opinion, and I'm going to share this with you both, that with testers, what I like to do when you have testers, tester, the QA person on the team, they are very. It's super. It's very beneficial to have such a person or even multiple in a team, but I don't like separating their responsibilities. Absolutely, the QA can find really good edge cases, and they are trained to to break the software and all these things. Absolutely, but what I like to do when there is such a case, the best is to teach the tester how to code, and the tester should teach the coders how to test their software. So they should mix the both, and I would say that's based on my experience, that's the most powerful combination. Because my issue with this, that let's say you write something, of course you try to test all the cases, then you push it to the, let's say, QA team. A lot of time they do it, which is not the best practice, having a QA team. And because, then after you have a big delay. You create something, you push it, and after that, QA team, we find something, push it back, it takes days. But we should achieve, let's say we want to release every day or every second day, it's very difficult. But going back to your question, absolutely, the QA person can work with the coders to find out the cases, so they can start with the failing test, and so we start the failing test, and after that they can follow the TDD flow. They make the test plus and refactor. So I would say QA person, the main role of a QA person should be, or a tester should be, to help coders to have this testing mindset and help them to what are the best practices to break the software.
Yeah, let's get back to that later when we talk about learning topics in this area.
Absolutely. A great question. Thank you.
Great. So one thing, from your conversation we had, Daniel. So you mentioned that something called BTD, right? So it's like whenever people talk about TDD, they talk about BTD as well. So is it like BTD is the output of TDD, or how they relate, or what's the difference between them?
Yeah, this is also a great question. So BDD, the behavior-driven development, you mean here, right? And I would say TDD it is a one sort of behavior, BDD. Of course, BDD in the industrial sense, that you have this, the Gherkin language. They associate BDD with Gherkin and all these things. But I would say TDD already a BDD tool, and you don't need Gherkin and Gherkin syntax and Cucumber and all these things. You don't need to use TDD, and TDD is already a behavior-driven development, because again, you specify behavior you want to implement. So in that sense, yeah, TDD can relate to behavior-driven development, because as I mentioned at the beginning, with our tests, we target behaviors. And that's what you do with BDD, that you try to figure out the behaviors of the system, and after that you write some high-level test, which can be read by, the product owner, the users, or everyone, or every non-technical people. So, and after that, based on that, we can implement the stories.
So one question we often get, I'm sure you, as someone who is promoting these practices, right? So there are challenges adopting TDD, and do you think TDD is for everyone?
I feel that everyone should have in his or her tool set. because TDD cannot be always used. So, there are things, and as I said, TDD, once you use TDD, you write code, it has a good test suite, a very good test suite, but you still need to use other testing practices. And, software engineering is much more than coding, right? We have to collaborate with the customer, figuring out what they want, working in short cycles, collaborating together. So software engineering is much more than that. But TDD is one of the, for me personally, one of the tools which is, every time when I write code where I know the requirements up front, or even just, not the full, but, something to get started, then it helps, and it helps in a lot of senses. So absolutely, it is for everyone. And even they say that you cannot use TDD for front end, but yes, you can use it. I use TDD for front end. React, for example, has a very mature testing ecosystem, and you can write really good high-level tests with TDD. As I mentioned, the example, let's say there is a form where the user needs to fill something. They click on verify or on a given button. After that, something should be displayed on the screen, and you can perfectly TDD it, and you don't need to use Cypress or such things. You can render the things in the memory as well with the React testing library. So I would say, so here is the thing. So the question is TDD for everyone or not? So it's up to the given person, what they prefer or where they put their emphasis on. I never met a person in my career who used TDD for a longer time, and after that they stopped using it. Really, never met. And it's really a proof for me that writing code with TDD is you can have better results, and you can in a safer way. I don't say that you cannot be successful with TDD. No, not at all. I know people are successful with TDD, respect them, and they don't want to use it. Totally fine. So I think this is not the only way to write code, but this is the safest way to write well-designed code, I would say. And because without that, as I said, you have different kind of issues. For example, okay, once you write some code, after that you have to write some tests. You have to make sure that you cover all the parts. So you need to use code coverage. And we discussed code coverage is not enough. So you need to use mutation testing, which is another complex tool and practice you need to apply. And it's continuous hassle to use these tools to produce a good quality test suite. But with TDD, you don't need to use these tools, or you use these tools as a quality check. So TDD helps me to reach my goal in a faster way. And everyone around me, or everyone where I worked, really everyone says the same. So it is a proof that really TDD is a methodology or practice that really everyone should give it a try, or even give it a try, just give some time to it. Because if you give it a try, it will feel different. And it goes to the challenges, that whether it has challenges. TDD, the rules of TDD is simple, but the execution is complex. And it's like the poker. The rules are simple, but to be a master of it, you need, a lifetime. And similar like TDD. Because TDD is not just about, I mentioned that, you have this TDD cycle, red, green, refactor, and you have the 3 laws, and you follow this. It's not just about this. Because TDD is not something that you take and plug it into your development process and it works. So TDD is a complete entire way, it's complete package to test, design, and develop software. And it requires a lot of knowledge for you prior. Or even if you don't have it, you need to learn it along your way. For example, how to design clean code. TDD won't tell you how to name your software elements. It won't tell you which design patterns to use. It won't tell you this. Even TDD won't tell you how to architect your software. And even TDD will never help with architecting software. For example, that's a case where you cannot use it. So, but going back, so again, you need to know how to design code. If you don't know how to design code, TDD won't help you to write well design code. You need to know the basic, the practices, the clean code practices. You need to know how to test code. So TDD helps you, it gives you a lot of smells about your test, whether they are coupled to implementations or not readable or they are slow. So it helps a lot to put you in a direction to write good tests. But if you don't know how to write good tests, then TDD won't tell you. So therefore, what I say, these are sort of prerequisites of doing TDD. And a lot of people I met they said, TDD doesn't work. It doesn't help me to write better code, etc. And every time when I dig deeper with the given case, I realize, okay, it's nothing to do with TDD. It's about that they cannot write well-designed code, or they don't know how to test their software. And if you make mistake, let's say you don't know how to test your software, and that's the most common thing about people who don't do TDD, so they don't know how to test their software. So they write bad quality test, for example, coupled to the implementation details, and after that, every time they change their code, then their test will break. So test will become a burden, and they say, "Oh my God, my test always holds us back." So TDD holds us back, which is not true. It's not about TDD; it's about your test. And if you improve the quality of your test, then TDD will help. So I would say this is the biggest challenge. That TDD is not something that I start using it, and surely, if you start learning, after 2 weeks, you can already feel the benefits. But after 10 years of using it, you can still learn from it. So that's why it's a beautiful practice for me. It gives you a really well-defined, strict way to design, and safe way to design software. So I would say everyone should have it in their tool set, and use it for a longer time, a few months, give it a try, and after that, I wouldn't say I guarantee, but it's highly likely that you will get hooked to it and you will keep using it, because it gives you so many benefits and power that I don't want to write code without TDD. If I have a chance, I use TDD. Absolutely, that's my go-to tool.
So yeah, I mean, I keep hearing this from so many developers, like, okay, writing tests is actually slowing them down, but you answered it beautifully. It's not the test; it's about the kind of test you have written, basically.
Exactly.
Yeah. So Daniel, you said you have some diagrams to show, like, which will simplify TDD for everyone. So would you like to share that?
Absolutely, that would be awesome. So, because as I said, TDD is simple, but doing it is complex. But so I'm going to tell now and I can show you the simple part, how really the TDD flow works. And I already mentioned the TDD cycle and the 3 laws of TDD. And basically, this is the only thing what you need to do when you drive the design by writing automated tests. And this is what you need to know, which is quite simple. We can even learn it in the next 5 minutes, 10 minutes. So let's do it. That's an excellent. And for everyone who is listening, you can learn how TDD works. Chrome tab. So can you see my screen?
I guess we can.
Perfect. So as you see, this is, as I said, this is a TDD, the famous TDD cycle. So again, we have 3 phases. As you see, red phase, green phase, and refactor phase. So before we start, there is one law we need to follow. Namely, you are not allowed to write production code until have a failing test. So it means really that we can only write any production code if we have a failing test. So that's really the requirement. We need to start with a failing test. So you cannot bypass it, because that's as I said, the power of TDD, that we start with the failing test. So we have a red phase. We have to start writing with a failing test. Here we have a law, the second law of TDD, that you are not allowed to write any more of a test than is sufficient to fail, and compilation failure is also a failure. So it helps us. It enforces us to take baby steps. So we write a test, but something small tests, a small behavior we try to cover. We don't want to cover all the business functionalities and all the behaviors, just a very small part of it, a sub part of it. And once we have it, we have to stop. We have to stop and we have to jump to the green phase, where we need to make the test pass with the simplest solution we can come up with, because here we have the law, the third law. You are not allowed to write any more of a production code than is sufficient to pass the failing test. So in other words, we need to come up with the simplest solution. And once we have the solution, the test passes, then we have to stop. And so again, just to repeat, we have a start, we have a red phase, we write a small test, we go to the green one, we write the simplest implementation, which will pass the test. And of course, we can verify it by running the test, what we have written. And if it passes, we have to jump to the refactor phase. And this refactor phase is really the main phase, I would say, not the most important, but the main phase of TDD, because here we do the design practices. Here we do renamings and all these things. And as you see here, can we refactor the code and the test? because the tests are also first-class citizens, so we should pay equal. We should have high quality standards for the test as well. So here with green phase, we do some refactoring, a small one, not like okay, let's refactor everything. A small refactoring. We run all our tests. They are passing, yes. Then we can stop, or we can go again and we do small refactorings. So that's what we need to do here. We have to keep repeating refactoring in small steps. And after that, basically, and that was it. That was one flow. And this what you see here, this flow should take maximum 2 minutes. But usually this what you see here, this whole flow from start to end is just 1 minute. So you start with a failing test, you write a very little test with the behavior. After that, once it fails, and of course you need to run your test to verify whether it fails or not, then you jump to the green phase, you make it pass with the simplest solution you can come up with. You run your test, it's green, very good. So we implemented it, and after that we refactor. And that's what we keep continuing. This is the TDD cycle, and we keep repeating it, and we keep adding more and more and more behavior. We gradually build up the software. And the benefit of it, that we run our test every, I would say, 15 seconds, all our tests. And that's what I mentioned at the beginning, right? And that was a good question. You asked that, okay, what kind of test we need to use? Doesn't matter the naming. What matters, it has to be fast, or they have to be fast. Why? Because as you see, we continuously run it. And there are also tools I'm using. For example, nCrunch for Visual Studio, but there are also other tools. I think Wallaby.js for Visual Studio Code for JavaScript. And what these tools do, they run your tests all the time. Every time when you even just add one keystroke, something, you just press one keystroke or add a new word or whatever, your tests are executed. And that's the power of TDD. Your code is always working. And that's really the trick of TDD, or that's the trick of safe software development. You should never let your code not working. So you should always keep testing along your way. So it feels, maybe for you and for anyone listening, it might feel a bit, okay, it is not the way how I coded so far. Like, okay, I don't run my test just, I don't know, like first I write a lot of code, then I test, and after that I run my test. And here what I mentioned, I run my test all the time, always, or if I have this tool, I run always. If I use some tech stack where I don't have these tools, I run them every save when I save my code file, which, I click on it, I don't know, every 20 seconds or every multiple times per 1 minute. So basically this is the TDD cycle. And that's what you are designing software by using this, and by following this TDD cycle. As I said, you end up with a test suite that is you can trust. You end up with a working code and also simple code, and also well-designed code, because the refactoring phase you have in every minute, every 2 minutes. Let's say the cycle time is 2 minutes. Then in every 2 minutes you need to do some refactoring, or surely you have a phase which reminds you to do some refactoring. It reminds you. You don't. It doesn't mean that you always need to refactor, but most of the time, yes. So you see, the refactoring won't be an afterthought. It will be something core to your development process, and you keep refactoring your software all the time. So you will end up in a code which is taken care of.
Last, you have any questions?
Absolutely.
Well, this is what is great about one of the things that's great about test-driven development is when people say that testing takes too long and so on, they don't have time for test. It's first problem is if they don't have the proper setup. That alone can take a lot of time, and if you're not familiar with that, well, how to even get started, and if you're not motivated to do so, it'll take even longer. And like you mentioned earlier, if you don't have experience writing good tests or tests at all, it'll also feel very, very slow. You need some time to get into this rhythm. You need some pointers in how to write the right tests and good tests. With TDD, it's the other way around. You're getting the benefit upfront from the test, rather than this is something we have to write at the end of the development cycle just because someone wants the code coverage or whatever. So here it's helping you throughout the entire development process from start to finish with make, like you said, that you have runnable code. You have already run it in several different cases, even before it's part of any production environment app. Contrast that to spending a week implementing something and then deploying it to environment and sharing it with your stakeholders or whatever. And then there's a few bugs because it's the first time you've seen the system as a whole run. And there's all these small edge cases and things that don't work well together and so on. At least when you use the test-driven development, you can do it both on the very micro scale, on the individual classes or data, whatever your functions, or but also on more of a mid-level scale where you integrate several pieces of software together and write the test for them. And then you switch between this more macro scope and then back to the microscope. So you write a macro test, it's failing. Okay, so dive into, okay, now I need to create this class or this function. And then you go to the micro scale of TDD there. And once you're out of that loop, you go back to the macro scale and have a bit more high level test that integrates several functions and classes or whatever you need.
You got it. Absolutely. I like these kind of people who understand TDD early, exactly the power of it. And so you mentioned that, some people write tests afterwards, and I have not a theory, but sort of reason why people don't like testing that much than for example, we TDD practitioners, because they do it after the fact. And when you do it at the end, it feels like a chore. Oh, as you said, someone stakeholder, product owner, right? The tech lead told me that, hey, this code should be tested. So I spend a lot of time on it and I have to test it. And it's tiring and it's chore. But when it's an integral part of your development phase, then it's fun. It's really TDD gives you a game-like feeling to write code in a turn-based way with always having some exact goals to achieve. Always write a small test. Okay, let's make it pass. Let's refactor it. Let's jump to the next. So it really gives you a game-like feeling, and it really makes fun, and it's a joyful way to write. And after the fact, after we've written the production code, all this joy has faded away. And I like that. Personally, I'm a big fan of testing. So even if I happen to, or I need to write tests after the fact, for example, for integration tests, which are slow. So for that, sometimes I go for, I don't go for TDD, so I go it after the fact. But I even enjoy that. But when I do tests, I write tests with TDD. That's my jam. That's the best. That's one of the best feeling of software engineering for me, and seeing them green, of course, because and it gives you confidence, because you always see your code, you always have your code working because you run your test all the time. So always, of course, you can have mistakes. We are humans, and such things can happen. I don't say that it's a bulletproof, but surely it's a more fun and a safer way to write code. But yeah, great points you brought up.
So, what about when a team is adopting TDD, right? So, what are some of the best practices they should follow? What is this?
So exactly. So I mean, if you read about TDD, or if you listen to this and you want to start using, let's say someone listens to this and okay, we listen to this from Daniel and Santosh and Lars with this amazing podcast, and let's apply TDD. I just learned this from this guy. I'm not sure it will work. You need to. Again, I think the most important thing, it will work if you, first of all, care about that your team has the skills to design, design clean code, or, write well-designed software and have good testing skills. You need these two. And without these two, don't start with TDD, because you can end up having a lot of issues, which is not because of TDD, but because you cannot do this design. And since TDD, you need to write fast tests, decoupled tests, dependency injection, different kind of mocks. Doing refactoring phase is one of the most important, where you need to keep refactoring your code, well-named software components, design patterns, different code smells, removing code smells. If you don't know these, TDD won't help you. So I would say if you are a team, first, get familiar with these things, the design smells and patterns and these best practices of writing code and writing tests. And once your team has this knowledge, you can start with TDD, but don't start in a big, big feature, but keep it small. First of all, maybe you can try out with the katas. These katas are small exercises you can use. You can do 1 or 2 just to, get familiar with it. But katas, nobody will pay for katas. So you can try out on some small function you are implementing, or a small class or a small feature, and give it a try. And don't, keep up with it. So keep practicing it. And I said, after 10 years, you can learn from TDD. So surely you need these prerequisites. So writing well-designed code and testing. So that's before that, you don't start. You can start with TDD, but then do TDD and at the same time intensively learn these things next to it, and it will be fine. But the best is if you have someone. The best usually is a technical coach. If you have a coach next to you and who can help you, that can speed you up. So without it, and I'm not saying it because I promote myself. So it's not about that. I'm just saying that a good coach can speed you up. Can speed you up in 1 week. But it's not only about TDD in any kind of things. I don't know. You need to do whatever, some React, Angular, Kubernetes, or GraphQL, or whatever skills you want to pick up, or pair programming, more programming. Once you have a coach, you pay it for 1 week, and after that you can put you up to speed, and after that you can go alone with your team with a given practice. So I would say, but if you don't want to have a coach, then absolutely make sure that your team has necessary skills to design well-tested software.
So as I have both of you here, I mean, and if you don't know, Lars is a very big advocate of testing as well. I mean, when I started my own podcast, I mean, I actually invited Lars for our first podcast season, first podcast episode, and we spoke about testing actually. So
Cool.
I have seen this trend in the industry. Like initially, there was time that people said, "Oh, test is best of time." Then people said, "Yeah, we need 100% test." Now people have accepted the fact that 100% code coverage is not going to help. So we are okay with let's say 60% or 80%.
Okay.
But the challenge is what that 80% should cover, where the developer should focus, what I'm going to test in the 80%. So what is recommendation from both of you?
Well, so yeah, this is so again, if you use TDD, whether you want or not, you will end up with a code with 100% code coverage, or very close to that. Every code you write. So again, if you're going back to the TDD cycle, how we start with the writing with a failing test. So every code we write, every behavior we write, we will have assertion. We will have test for it, because we cannot write code if we don't have a test, right? That's what we discussed. That's the first rule. We need to have a test to write code. So this really, it's just by following this flow, you will end up with the code 100% code coverage or very close to it. I'm talking about the business logic. I'm not talking about, of course, when you run the code coverage for all your project, of course, there will be parts which are not covered because, some infrastructure, there might be things which won't be covered. Of course, as I said, TDD mainly for the business logic, the business domain, the core part of your application. And for that, you will end up 100% code coverage. And not only code coverage, as I said, it is a misleading metric, and I never really use it. I rather use mutation testing, which helps you, which are the things which are asserted in your test. So, yeah, I mean, what to say? I mean, you end up with close to 100% with TDD. So I don't have 80, 90, or 70. Of course, for the whole project, something like 80 would be very good, because you have things which you cannot cover with test, or very difficult, or it just have a diminishing return, right? So it doesn't make sense, or the test what we write is not meaningful. So don't write tests to increase code coverage. Write tests to gain confidence, and that's what for me TDD about, to write tests to gain confidence, because I'm confidence in the business logic, in the business behavior. So I would say this is the focus what I follow, or where I put the emphasis on, to write tests to gain confidence, and with TDD I get this confidence.
Lars, you want to add?
Yeah, I think you should, if you're experienced in these topics, or if you're not, then find someone who is. spend some time thinking about a testing strategy. So an approach that makes sense to your systems and the teams you have, the tools you have or you want to use. Of course, make sure those are in place, but they should also match the direction you're going. For example, if you're in the situation of you have a massive code base and there's no automated tests, and the teams have never written any or maybe just a few automated tests. So how do you proceed from there? What's a good testing strategy? Going straight ahead to test-driven development might be too big of a leap. So maybe just start with basic and maybe start with, for example, more end-to-end tests, where the test itself tests a lot of code and from a user behavior perspective, because the thing about unit tests, which is a major part of test-driven development, is you really need to have a strong understanding of maybe the frameworks and libraries you're using and how you set them up for tests, and then how you use the different testing libraries as well. And if you don't have experience in any of that, maybe you're even new to the framework that's being used in your front-end or back-end application, then you need to train more before taking on something like TDD, in my opinion. That's also when I tried it first, I found out that I wasn't skilled enough in Angular and in particular in the testing tools that are available in Angular. And that's how I learned that there's about 75 different techniques to test different Angular-specific pieces of software using the tools provided by Angular. So first I have to learn all of that before I can even start thinking about TDD being useful. So like you said, you need prerequisites before taking that step.
Exactly. Couldn't agree more. Absolutely. You need these. And these are the three, again. It's just to summing it up. So surely designing, clean code or, writing well-designed code, testing your code well, and of course, testing with your tech stack. How to test it with your, what kind of libraries you have, and how to write good tests, targeting the behavior, how to mock. That's also a crucial part, how to mock, different kind of test doubles. These. You need to have these for TDD to really be successful.
I'm evaluating a new tool right now that's quite unique. It's called Meticulous. It's AI-based, and basically they write tests for you. They are more like end-to-end tests. They test via browser.
That's
but
cool.
You're not writing the test at all yourself. The AI is writing the tests. So you can record user sessions in the browser.
Oh wow!
And then it figures out which user sessions are the most common and the user flows, and which one goes through most of your code, but also the control flow in your code. So it tries to optimize a test set that is most relevant and the broadest in some way. So it's a hand-free development experience kind of. So, and I don't think this should replace writing code as a developer, but it can be a good tool, especially also in the context we're evaluating it, where you don't have any automated test suite for just out of the system, right? So it's a good way to get started, but also it's quite unique. This thing that it continuously evolves the test suite. Of course, there can be some privacy concerns, so you have to think hard about whether you're even allowed to track your users that much, right? So maybe it's opt-in or maybe you use it only for internal purposes. I mean, one use case is just only enabling it for developers, but then do you really get the real world use cases, which is more useful in this context? So that is kind of an automated testing strategy. The AI will figure out which tests make the most sense at the current point in time based on the newest state of your system. So that's very interesting. That's very
interesting. Surely surely I think these things can help. And as I already mentioned at the beginning, the TDD good for unit tests, but apart from that, you need to use other testing practices such as property-based testing, mutation testing, beta testing with the users. There are a lot of other integration testing, contract testing, and also this AI, the end-to-end testing. So absolutely, we need to use these tools to achieve high quality for a given software and to make our customers happy, right? That's our most important thing, to write software which delights our users and make them happy.
Thank you. Thank you, both of you, for answering this question. So, Daniel, we are almost at the end of the session. So, one thing which I want to know is, what are like the resources which you recommend to learn about TDD?
Mm-hmm. Yeah, surely we have the tddmanifesto.com. I can send it to you, which we created back then with a few friends of mine. Here I'm sending to the comment, or no, in a chat, private chat, and you can maybe show it on the screen. So surely we created it back then and at that time we also launched the conference, the first international test-driven development conference, with a lot of speakers, keynote speakers. It was a free event. 2021, it's on YouTube. So if you really want to learn more about TDD, over there you can surely find more things. Another point which can be good, of course, I'm also an organizer of Tech Excellence conferences. We are doing it every second week, and we have been doing it for a long time. And over there, if you write Tech Excellence TDD in YouTube, you can find surely a lot of sessions also for writing tests for UI. So I recommend those as a recent resource. And of course, I'm regularly posting firing posts about TDD and writing newsletter as well. So if you check that out, you can check out Daniel Moka on LinkedIn. And I have a newsletter called Craft Better Software, where I have a few articles already about TDD. And this year I'm really doubling down on this topic, and I'm spending more and more time on this. So check those out. That can be a great source, I would say, to get started. But sure, this TDD manifesto can give you a good entry point to start. And also here I talk about how to write clean tests. So that's what we discussed. That's one of the requirements, not only about designing clinical clean tests. Over there you can learn the main best practices about writing clean tests, which can help you with the TDD flow. So I would say these are great resources to get started.
So Lars, do you have any recommendation for resources?
Yeah, I'm sharing the TDD manifesto website right now. Maybe you can just put it on the screen for people to see who are watching the video. So you're part of this, Daniel?
Exactly. Yeah, I would say I was the one who initiated this creation, and I asked a few friends of mine back then from social media, and we did it together. But yeah, I am the author of this. And as you see, we have the values of TDD. We can say what is not TDD, and what's not used, and the get things. And you can go to the get things started. I would say that's a great place. You see, you have introduction, what is TDD? You have a clean test, and you have some exercises you can use to get started with TDD. I would say this is a great place to get started with TDD. It's simple, and yeah, that's what we wanted to come up with. It's a simple way. And this was we announced this TDD manifesto on the TDD conference I mentioned.
That's awesome. There is one more thing I would like to share, and you made me think of, because it's this notion of continuously getting better at writing code and getting better at writing tests and so on. And I'm reading a very interesting book. I don't know if you're familiar with it, but it's called 50 Quick Ideas to Improve Your Tests.
Oh, no. Sounds good. I don't know. 50 grid. No, let me show. No, I haven't heard it. Who is the author?
Yeah, I will send you the link here in the chat. It's
cool.
a red book. The authors are called Gojko Achig, David Evans, and Tom Roden. It's not a completely new book, but I purchased it, I think last year or something. It's been on my watch list for a while, and I decided, okay, I'm going to buy this. And I haven't read the whole thing yet, but I'm really, really enjoying what's there so far, because it really makes you, it's like qualified testers or developers, whatever, I don't even know what they are by profession, but they're just sharing tons of experience, and it's called 50 Quick Ideas because each topic is a few pages. So you can grab the book and dig through just one topic in a few pages. That's a few minutes of reading, and you'll learn so much, especially about this. Well, I don't even know which test can I have test coverage, whatever, or maybe I'm not even measuring it, but which tests can I write? And how do I think about edge cases? And what different types or categories of tests are there? And I don't mean unit test, integration test. I just mean what could you what could you consider? Which categories of tests should you have? Okay, you have, for example, just the simple thing of a happy path, exercising your API, whatever, and then the failure path. With errors, but even there, it's much more complicated than that. There's so many nuances to what you can cover in a test, and I learned some of this in person from a very qualified testing professional. But this book is just like continuing that educational journey for me. So I'm really
cool.
I highly recommend this book.
Go check it out.
Ideas to improve your tests.
Okay, I'm also gonna check it out. It's surely I can also learn from it. Absolutely. So there is always room for learning, huh?
Yeah.
Awesome.
So all the links, all the links are available in the description, so you can go through it. And yeah, so we'll end this soon, Daniel. So like we generally ask our guests to promote something on our channel. So would you like to promote anything which interests you?
I would say check out my newsletter. That's a great one, and I already have 12,000 people reading my newsletter. I'm sending you the link. So yeah, check it out.
Wow.
I would say this, and here I have great plans for this year, doubling down the topic of TDD and other cool stuff. So here I'm going to share all these things with my audience. As I said, I have 12,000 people reading it, and they like it very much. I have good remarks. So yeah, check it out, I would say.
So thanks for joining, Daniel. I mean, it was a great discussion, and it was great having you on the show. And probably we'll do another episode soon. Maybe we can invite you again on the show to talk more about testing. And yeah, so that's it for the day, everyone. And we will be back with another episode. And that's a very interesting topic. I mean, me and Lars are really excited to actually speak to the team. So it's all about open source funding. And we, of course, like everyone has a good interest in open source funding. And somehow you want that to be taken care of. And it's a very great initiative from a company called Polar.sh. And we will be talking to the founder of the company to see like how they are trying to fix this issue. So see you on the next episode, and goodbye for the today. And thanks for joining, Daniel. Thanks for joining us. And yeah, see you soon.
Bye.
Thanks for having me. Appreciate. All the best, everyone.